Hey guys, welcome back. Today you're going to be working on 2.1E. Your goal in this, let's see, your goal in, here we go. In 2.1E is you're going to be modeling how solids, liquids, and gases move on the molecular level. We can see them in a macro scale when we look at them, but we really just can't see what the individual parts are doing. And so since we can see what the parts all together are doing, we can kind of figure out what the individual parts are doing. So down here at the bottom, you're going to need to click on this PhET simulation, and that's going to bring you to this. Don't forget where number 1 says, make sure this lab on workbook 12 and 13, that's what you're working on. So the 12 and 13 page, it's in your workbook, and it looks like this. Looks like 12 on the bottom and 13 on the bottom. You got it, and I'll show you how we work through there. And so the first thing you should really do is kind of play around with this. You're going to work only on the states. And no, not the states, the United States, but the other states, the states that matter. And there's a few things going on here. You'll see that up here in the top right-hand corner, this is what you're looking at. For example, right now we're looking at neon, and neon's an element. So it's just, you can see one color here. Argon is also an element, so you can see one. Since oxygen is a molecule that we breathe in, you can see they're in pairs, so they'll move in pairs. And water is an element, water is a compound because it has H2, 2 hydrogens, and an oxygen. And so you can see how the different colors represent the different elements or the different molecules or the different compounds. So starting with neon, for example, you can see how they're all together. They are vibrating, and you're going to look and see how they behave. So without doing anything, I suggest that you play around for a little bit and just watch what happens when you increase the heat. You'll also notice the temperature is increasing as well. Hey, it looks like ping pong back over here, tennis. And, you can do the opposite from there. You can remove the heat, take away that thermal energy, and you can watch all the pieces as they go back down. I encourage you to, look at argon, see if argon behaves differently when you add heat, and oxygen. If you want to change the matter, whether it's solid, liquid, or gas, for example, this is neon in a solid, but here's neon in a liquid, and here's neon in a gas. Same with oxygen, for example. Here's oxygen in a solid, oxygen in a liquid, oxygen in a gas. And as an example, right here in this first box where it says solid model of neon, you would be clicking on neon and you'd click on solid. And this is what you would draw. You would draw how the molecules are all together, or the elements, the atoms are all together. And since they are vibrating, if you want to show that they're moving, you can put one line around them. That probably help you out a little bit. And when you're done with that, you'll be going on to the next one, which is what is the solid form. So you're going to do the solid model of neon and then the solid model of argon. And when you're finished with neon and argon and oxygen, down here at the bottom for each section, when you're looking at the solids, it's asking you to write out the similarities and what they all have in common. So you're going to do that for solids. You're going to do that for liquids. You're going to do that for gases as well. You'll complete page 12 and 13. And this is your activity for today. So enjoy. Oh, I forgot a joke. Oh my gosh, joke at the end. Okay. So if vampires can make a holiday, what would they make it? What would they name it? Fangsgiving. Ho, 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 ho.